So this is my first talk on testing that I've ever done, probably for good reason. It's quite an emotive topic. I've been at various conferences over the years where the talkers have been genuinely heckled, saying that's wrong. So I want to just go ahead there and say from the outset, if a test case or a way you're writing tests is helping you deliver better quality software, then just keep doing it. Don't worry about the ins and outs of what's the best way to do testing or what's the most perfect way. But there are better ways sometimes. So this is a bit of I called it a rage submission, didn't I, Dan? I did, yeah.
And I immediately picked you up on it.
I just smashed the keyboard because I'd realised in one of the test cases that I was seemingly passing the functionality that had a bug. The actual TLDR of it was that only that specific test case would ever pass, as in like the test case and the functionality had been written together, obviously. And a lot of the kind of words that we saw in that test case were along the lines of "foo." You never guess what's coming next. Testing! And look, no hands, which is actually a coffee shop in London. So yeah, I was working for a takeaway company, potentially this one. And yeah, blank. That was another one where you just got strings, so I'll chuck it in there. And these are all kind of the stubs that we'd all write. I've written them. I continue to write them, in fact, into our test case. But sometimes we unknowingly actually degrade the quality of our test case because, as in this case, only one item was able to be added to a list at any one time because this test case had been written with an array initializer within a for loop. So essentially, it was initializing the array, adding to it, and returning each and every single time. And of course, the test case just assumed that there's one item in the array because that's the only thing it could add in a fixture. And it's all generated this kind of talk around evolving your test cases as much as potentially we evolve our code. I don't know about you, I've been worked in Android the last 10 years, and I have done a new MV star every year. I think it's pretty close to every year. Apart from that time I was doing management. And I'm pretty sure we were still using JUnit until just recently. JUnit 3 that was. And JUnit 3 came back in, I don't know, the 90s, I don't know, a long time ago. So test cases tend to evolve much slower in my experience. But it might not be the same with your experience. Maybe you've adopted that mantra that you should evolve your test cases, treat it like production code, etc., etc. In my experience, I don't personally. But every now and again it goes to this massive leap where I upgrade to JUnit 5 from 3, or I upgrade to Assert J. So this talk isn't going to be about my app for once, if you haven't seen any of my other talks. I've learned my lesson there. I'm going to try and do a bit more abstract. We're going to talk about a Meetup. I'll explain that in a second. And we're going to go through 1, 2, 3, 4 different scenarios. The first one you'll be very familiar with if you've written Java. It's Java and JUnit 4 together with stubbing and mocking in order to verify behaviours in a test. Then we're going to move on to Assert J, which I'm sure you've used as well, where you write words like assert that this is equal to, together with fixtures and fuzz. And that's where the title of this talk came from, chaos mode. Within my personal application, I wanted to kind of generate random data that was always valid. And it turns out this had a word, it's called fuzzing test inputs. So when I set up a test, and maybe my restaurant name wasn't Look Ma No Hands, I didn't actually care, I just needed a restaurant name for validation. I would get some fixture to generate me some random data, which is different every time. Sounds a bit counterintuitive for a unit test, but it's different every time and randomized. And what that means is that I don't actually care about this piece of information. And it turns out this has got a big word, a big following around it called fuzzing, very popular in the security realm where they use it to try and identify problems in software. We're going to then move on to Kotlin, because I can't do a talk anymore about Java and Android and all that stuff because it's not cool. So I've literally been learning Kotlin, Kotlin DSLs in particular, having gone to a workshop with Hadri Harry, one of the movers in that realm, and I was very impressed. So it fitted in quite nicely with this whole idea of the chaos mode. And then we'll look at what we can do if we merge the ideas of Assert J with Kotlin DSLs with fuzzing, stubs, and a framework which I've been introduced to at DroidCon, if anyone else was there, called Elmer, which is a specific Kotlin fuzzing framework. Finally, if we have time, 5 minutes in already, I might show a picture of my app. I'll show you what happens if you actually run these fixtures in your production app. So, what is the scenario that I'm going to be running through? This is our meetup. It was yesterday anyway. Attendees 50 on the waitlist. My awesomely contrived user story, because I don't know, they always tend to look a bit like this when I write them. As a user of Meetup.com, when I view a future event, and I can see how long the waitlist is. So that's all I want to do. It's a simple function that looks at the capacity of a venue. Currently this one's 50. Nice! Much more. And number of attendees, and subtracts the two numbers. So our test case is literally subtracting one number from another, and it's going to have many bugs that we won't be able to see from initial scenario. So, yeah, as I said, the first version is going to be in Java. It's going to use stubbed, which don't be scared if you're confused between these concepts. I still am, I reckon. So stubs are canned responses. They're always going to return the same thing. Mocks, objects with set expectations, things that you then verify after your test is completed. That's a mock. So if you're using Mockito, you might be using stubs or mocks. That confused me forever. Okay, so this is our plain old Java class. A Java object called a Meetup. Our Meetup has an identifier. It's a UID in this instance. It has a name. In our instance, November Meetup. Has a time, 6:30, November 13th, and has some sort of dependency that it needs the attendee repository. It's going to get a list of attendees. And our test case that we're going to look at, the first instance, this is JUnit 4 with just plain old Java. It's going to look a little bit like this. Can everyone see this okay? I've been trying to make this readable. I think it looks alright. And I've written so many tests like this. You've got your assert, act, given when then scenario. We've got in all the things that we need. We've got some mock dependency being passed in called the mock attendee repo. We've got some stub UIDs, this thing I've just assigned. I've got in some random address, the foobar testville. Who's got foobar testville in the code base right now? Hands up. Liars. We're all lying. I've got some stubs by way of when, then return in the Mockito land here. And then I've got some assertions. So the deal is I've got a place with a capacity. You can't really tell there, it's the point. Can't really tell if you look at the hover text. And I've got 65 people wanting to come. So my waitlist length is going to be 50, 65 plus 50. So let's run the test. Run the test. It's going to be fine. It's going to pass. Whilst that's running, anyone want to shout out annoying things about this test case that might have resulted in my rage submission? It's quite bad to read. It's very difficult to kind of get it at a glance if I wasn't explaining walking over it. What on earth is this thing doing? So ignoring the underscores, I've got to do that in the same namespace as the other parts of this talk. But so say I had a test case called test meetup, so that's the action, and the behaviour is calculates waitlist length correctly. The test meetup calculates the waitlist length correctly. So it's quite readable in that respect. But I'm just like, why do I need all of this stuff in order to just basically do that and maybe this thing at the end, verify that a certain thing was called. And ultimately, it's plain old boilerplate. We've got in the meetup function the actual code there. That's all it's really doing, and I've got to do all these other things around it. I'd rather if it was more concise. I'd rather if there was a way in which I could just get rid of the information I didn't care about, and only give in the things that I do care about, which in this case is the capacity of the venue. Don't care what venue, any venue, don't have to be just the and number of attendees, which I think are coming to the event. So that's what it looks like. I said, very familiar looking test case, written lots like this, JUnit, stubbing, mocking, quite standard. And specifically, we'll just home in on those, which comes as first. They're the items I want to get rid of. So I don't care I don't want to write about a random UID. I don't need to have a something parameter test. I can't remember what that was. Name. I don't need to have a time for this event. I certainly don't need to be in Testville in the middle of the ocean. And then, and probably the most thing that's wrong about this test, asserting a list as a size that has no entries. So I didn't add anything into the attendee list. I just says, hey, Mokito, you've got a size. Return 65, whatever I said. And if you go back to our picture of our meetup and then overlay what that test is actually saying, it looks a bit like that. So I said now, the meetup's now, it's always now, regardless. So time zone bugs are going to find your way into this area here, be using locales, default locales, and not fuzzing that. We've got a location of Foobar Testville. There's your 00 coordinate in the middle of the Atlantic. We've got 50 on the wait list, and we've got these just blank spaces where profiles would probably be of people. But they're apparently in this list, these non-existent people. Ultimately, it's lying. This test case is lying everywhere in order to test a very brittle line through the code base. And I don't like that. Okay, there it all is in summary there. I've also used a cert equals, which is the built-in one for JUnit. You can make error messages with a cert equals to be very readable. They give you a little string, a little rationale at the start, and then your expectation and your actual. But most people don't, in my experience, as in like I don't. I just say cert this equals that. So when this test fails, I can make it fail. It just says, I don't know, 14 does not equal 15. I'm like, I know that. I know it doesn't. It's worse though, aren't there? The cert true is false. You're like, the expected true was false. Oh, great. Thanks for that. And you know, when I'm sitting in my own personal projects at home writing these shoddy test cases, I don't have a problem because I'm like, oh yeah, cert true false, yeah, I got it. It's not the right one. But usually when you come across the test failure, you're coming at it blind. You're coming at it just as you saw it then. Where you just got this big mess of code, and you're not really sure exactly what this is trying to do. And you know, there's some magic numbers going on in there. Great blog post recently about whether magic numbers are okay in test cases. TLDR, was it? It's probably okay. But you want something more descriptive. So we can go on to configuration 2, so the second blob I described at the start. So this is where we're going to start to get into our chaos. And how do we generate venues behind the scenes, as I was seeing there, the food bar, Testville. How do we generate attendee lists without having to go through the rigmarole of actually writing it down? So fixtures is the way in which you do this, test fixtures. I think these are most notably used in database-dependent test cases where you initialize some in-memory database with some data and then unit test it by executing a SQL against it. It's an integration test, but sure. It's a very useful test that I continue to write. And this configuration is also going to use a sitj to kind of improve that error messaging at the end, which is a fluid decision library. More recently, there's another library called Truth. Because Google like rewriting stuff that the community's already done for years. So apparently that was written at the same time as a sitj back in the mid-2000s or something. And this is what I've called peak Java. This is when you're going to see like the most Java-y code of today. Okay, so what does that look like? So we've got the same test case, right? We want to calculate the wait list length. There's actually no code changes, as this is kind of describing here. I've just used the same namespaces as before. And we'll go on to test part 2. We can just briefly review what that test looks like. It's a bit better. So what have I done here? I've created something called a meetup fixture, as in I want to build meetups. I've created something called a venue fixture. I've given that venue a capacity. And I've tried to reduce it down to the portions of code I actually care about. It's not perfect, no, not by any stretch of the imagination, but in peak Java, it's pretty good, as you're going to get. The downsides of this approach are all the effort I've had to go into in order to generate this nice test case. And this is exactly how my toy app at home operates. I've got lots of fixtures behind the scenes that accept, just do the builder pattern if you've used Java or any other object-oriented languages you'd use to build a pattern. More recently, Kotlin has kind of destroyed its usefulness or replaced it, which we'll go on to. And that took time. That took a fair amount of time last night, at about 2 a.m. Yeah, so it took, say, about 45 minutes for me to write this all down. But it's much cleaner. Sorry, I'm just reminding myself which bit's next. We've got some meat, and I'm saying that the meat has a waitlist of length 15. It's a custom matcher. We'll come on to that in a sec. So the good bits of this, there's green in this bit. I said there's no green in the last bit, as I said right at the start. Don't worry, don't take offence. The test still works. It's still greenish. But I've got these kind of annoying little constructors going on, hiding some detail. It's not very pretty. I'd rather them not be there. They are boilerplate of some description. I'd like to remove from my test case since they're detracting from the end result of what I'm trying to say. Is that there's 65 people at this, 35. There we are, capacity 35, it's NDCAM 15, yeah, I've changed the numbers, good. And yeah, waitlist length is 15. So, better. The custom matcher, just quickly click over to that. Unfortunately again, Java land, you have to write it. It's obviously something which SHA provides out of the box with the abstract assert, where you can provide a very descriptive message about what went wrong. So no more assert true false. I'm sure you've probably heard of these things before, but every time I go to one of these talks, there's someone who hasn't heard about it, because this is going to rock their world. So you can actually describe in the domain language, leading on to configuration 3, what's wrong with your test case. So expect the waitlist with length blah, but was boom. Yeah, it's very verbose. Takes some time. Oh, Kotlin. Enter Kotlin. So, in order to make this talk relevant, as I was mentioning to a few people before I started, I had to learn Kotlin basically. Kotlin's DSLs replace fixture builders. They are a very powerful tool, which when combined with the aforementioned tools that you may be familiar with, end up with very pretty looking test cases. They require a lot of understanding of the Kotlin language, which I don't quite have yet, but I've been ploughing way through it with Michael in a tutorial during DryCon. It means in this instance we're not going to actually look at mocking. I've just removed that from this next bit of code example because it confuses things. We're just going to look at how we might put together the same test case if we were writing it in Kotlin. Okay, so on to part 3. Interesting. So in this instance, we've got this DSL called Meetup. Now this thing looks very intimidating at first glance, which is kind of the drawback. It goes back to kind of like, okay, so I haven't got an intimidating test case, but I've got this DSL that kind of build. Oh shit. In this instance as well, it's just stubbing. It's not returning like fuzzing. We'll get on to that in part 4. So it's still subject to the same kind of problems where I could initialize something with number 0 or null or 1, or potentially just have only one item in my list. But it does afford us some very pretty syntactic sugar with respect to the actual writing of the test and the building of the DSL. And this is kind of like how that whole fixture, our whole meetup might look if we were to use Kotlin's DSL method in order to build out a test case. So what have we got here? So we've got some sort of, I'm asserting in this instance everything about the test is being marshalled through. And this looks really cool. This is code. This isn't some sort of separate thing to Kotlin. This is actually a valid Kotlin code, which just amazes me. But essentially, this is everything about this current meetup extracted into a Kotlin DSL, and it's very powerful. So I can just say I want 52 other people and me, which is you guys and me. And in order to do the assertions, I combine that with the assert that. I've got some sort of question mark dodginess going on here. We'll talk about that potentially in the Q&A. Yeah, but if I'm using the same models as those I built in Java, and that is another real strength of Kotlin. So if I was to go back to our first test case, one of the things that this is not telling me is that this would fail very badly if I was to remove that part of the test. So I'm asking it to calculate a waitlist length for a place that has no venue. And we can certainly have meetups that have no venue. They are valid. They can be virtual. They could just not exist. There are no bunch of exceptions. And you could just say this is just bad coding. True story. But unfortunately, that assumption that you've got in the code, back up in the Java Pojo there, that the place is essentially something that can be added to this object after, is only clear to you as that author of that test at that time. Say I want to send out an email just before, as we do actually, do it manually via an announcement, that there's we've got a waitlist, and people can't come, please take yourself off the actual attendee list. It's pretty valid to assume that that code that's going to form that email is going to assume there's going to be a place attached to it, and ultimately that'll just go boom further down the line. And Kotlin really helps us out with that by highlighting that something's probably not quite right in your modelling. So inadvertently, by using fuzzing, where you can say whether a so if I go back to fixtures in 2, you can essentially choose to give something a venue or not. Then when you go to build it, if you haven't actually specified whether something has a venue, then just randomly decide whether it has a venue. If you ran that test a lot of times over, then maybe you ran it once and it'll say, yeah, I've got a venue, I can calculate the waitlist size. If you run it like 100 times, it's going to start failing quite readily. And every time your CI build goes through, that data generator.next boolean, we'll look at that class briefly, it's going to start returning a different answer. So that's a nice sugar. This doesn't have any fuzzing in it, as I mentioned, but it's very easy to read. So I can tell quite clearly what this is about to do. I might calculate the waitlist length. Oh, that DSL. About the things that I had to do in order to make that work, some of which I just thought I'd quite understand. I need Michael to explain it to me again. Lambdas with receivers, there's this funny little syntax of dot brackets. Scoping annotation to make sure that I can't put a venue inside a venue, like an inception venue. Ceph, single expression function syntax, which seems to be very widely used in the Kotlin language, and just default arguments. So all these things combined allows Kotlin to build DSLs. Okay. So what if we were to add fuzzing into this scenario? So I've got an example here using Excouché's Elmo. He did a good talk at Droidcom, and his example, his talk was also about fuzzing and how he'd always been using number 42 for all of his IDs. So every time he got them mixed up, he didn't know, because guess what? Everything's 42. So if he was getting a user ID or a company ID and passing the wrong one through to a function, that test passed. Verify arguments are 42. So we create this very useful library. Put it there, build it from source, but essentially it's got this idea of a forger. It's very similar to the data generator class that I just briefly showed. It just chooses a boolean, and unlike my homebrew version, which if I just go into that guy, has a lot of random stuff in there, so I can choose some ints between certain numbers. I can choose the next one of an enumeration, so if I've got a choice, day of the week, whatever, I can choose some random string. This library has got significantly higher fidelity, so you can choose a valid email. And that valid email, and I think if anyone's written a login thing, you've always forgotten that numbers and emails, and only numbers, are valid. So this kind of, again, instead of writing test at foo.bar, having a fuzzer in front of that test case, just going 1, 2, 3, 4, Chinese characters, underscores, spaces, and then making sure it's still valid. The email spec is insanely complicated. It'd be very difficult to kind of make sure that you've captured that completely within your test. So this framework allows us to write tests a little bit like this. So instead of just having a string blank, which is what I was having before, I would write forger dot as string, and that's going to give me some bizarre looking string. Let's have a look at what that string is. So let's just run this test. Perhaps I'll just comment that out just to prove that it's working to begin with. Talking about yourselves whilst copying the files here. Oh, didn't print anything, good. One sec. Yeah. Just quickly manipulate this test case. So all I'm doing now is I'm printing out the result. So complaining about the typo. Printing the result of this test case. Ooh, maybe.
Meetup link.
Oh. Didn't assign that a bar, did I? You all know how this feels. In a code review. All of a sudden you just can't write your name anymore. What's that about? Come on, let's go. Right, people at the back, you're going to have a problem reading that. So I did have a random GUI in there. So this is what this little random thing is there, is essentially the result of this function here. But yeah, name's always blank, time's always now, attendees are always blank, blah, 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 like that. So I'm going to essentially, by using the forger, change that result to just be a string. Any string, could be UTF-8, which will relate to our point number 4. Could not be. So what's it chosen? Oh wow, that's a good one. It's usually like blah, 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 blah. I don't know what to say with that one. So that's quite out there, that string. And we'd go through all of our functions. So with the zone date time now, if you were formatting that onto the UI, and you're going to forget about when you're formatting, you usually do something wrong, like remove the zone. So this will start highlighting those problems. I've got the Java equivalent that we can look at afterwards. And we can also just quickly keep going through this. So the forger has a lot of other useful little things on it. I think it says a sentence. So the venue builder is going to have a sentence. Okay, that's random. But for other items, I'll just quickly zoom in. These are all my blank attendees, because I haven't changed those ones. What other sentence did it give? No, just going right on the other side. Okay. Oh well, the well-known sentence of that. And this is where I start to see the most value, not in like the edge cases of, oh, it's that case where something, it's null and it's never going to be null, or something, I just made the validator wrong. But if you were designing a UI and you hadn't thought about if you translate it to German, it's long in German, really long, and you're going to start overflowing other parts of your UI. And perhaps, yeah, in your test case it won't highlight that, but it'll make you think. But what if you could just keep going and then put these fixtures actually into your running app. Well, I might have done that. So if we just quickly skip back to the slides. Benefits of that, as I said, fluent assertion, random data, it's really out of control, and benefits of using a Kotlin DSL make it very pretty to read. I'm at 30 minutes somehow. So where you put them in your app, so you don't have to live in your test cases. It's kind of inspired the name of the talk. We've all been building stuff without APIs, with dummy data. It would be a bit simpler if we could use the same fixtures that we're writing in our test, this nice DSL, and actually put our apps into chaos mode, as I referred to it. Again, looking at Android more specifically here, you could build a flavour out with the chaos mode activated, and instead of perhaps using your real SQLite database, you could use a fake in-memory database, or it could use a fake builder, or could just inject data into your app. So I've quickly mocked this up. This is exceedingly dirty. This is just how my app launches for the first time user. And I've added this little development element here, which is only available in debug, which gives me access to all this random fixture stuff and Elm and all the chaos you just saw. And turn it on. It will crash, by the way. This is not a perfect demo. That just got added. I've given it some control over one of them just to prove that it does work. Essentially, this is my app operating on some random data that's just been SQL'd into the database using my domain services. Not SQLs, but using the existing APIs, it just put some crap in there that's valid. I don't have any network here for some reason, but you would see backgrounds of all of our. It would show a background of the GPS if it had network. But if I tap the one above, who wants to bet me this is not going to crash? It's going to crash. Yeah. Okay. So what has this found? I know what it found. I looked at it earlier. I'm not escaping a single colon in one of my persistent services. So essentially it's injected some punctuation and I've got a SQL injection vulnerability, which probably leads me right the way back to the start of the talk, where it's popular within the security realm, because you can end up finding these sort of edge cases where you can potentially overflow things, or in this instance inject some SQL. Why this is like this, because it's a parameterized test case and it's using parameters that I control, but still, it's a bug. And it's finding things that I wouldn't actually write a test case for, just because it's just doing something random that's valid that I haven't thought of. So, in conclusion, buzzing helps you find bugs. Just putting some random data in there that you might not want to think of. It's not foo, it's not bar, it's not null, it's not zero, it's not one. It's it's that Chinese you just saw. It's out there. They help you write cleaner test cases. You saw in the Java example of part 2. There's far less guff in there around what's actually important. Don't give things values if you don't actually care about them for the test case, because they might confuse the reader. It makes it very clear the intent. Kotlin's type-safe builders blow my mind that I can just write things like repeat 50 and then just build 50 people that are valid on the side. And I think that has some real potential here for getting rid of that initial downside of doing it in Java, which is having to write it. So they've solved a great problem there. It also, as you saw the language problem, it highlights where things could be null, and maybe you did that wrong. Maybe you shouldn't be using question marks or double bang. Associated truth, better than options. And JUnit 4. JUnit 5 apparently is much better. Anyone use that? You can tell me about it later if you have. But JUnit 5 takes a lot of inspiration from Spock, which was generally referred to as an easier framework to work with than JUnit. More readable, I should say. If you're using Kotlin and want to do some fuzzing, then I recommend that library. And if I've not made any sense at all, which is a Swift developer or something, and I've just been never written a test case in their life. Not saying that's true, Dan.
Just going to ask how you knew.
Then just stop writing that rubbish in your test cases. It's fun at the time, but if when it goes wrong, or potentially you're actually introducing a failure path where your test case is the only thing that's valid because of the implicit assumptions in the author. Yeah, don't write acid. I think that's about it. Yeah.